So starting with, what is a quadratic function? A quadratic function in our standard form is going to be, well, I shouldn't even call it standard form. So this is where it's going to start to look a little different than what you did in previous classes. Our book refers to this as general form, which in the past you called standard form. Ax squared plus bx plus c. This is the guy we use with the quadratic formula. A is a number in front of the x squared, b is a number in front of the x, c is a number that's all by itself. Our book then calls standard form this guy that you see here. In the past, your book referred to that as vertex form. I still like to think of it as vertex form because it's easy to calculate the vertex from that form. But the wording is going to look a little different, so you're going to have to be careful. General form, if it's asked for that, it wants like the fooled out version. Standard form, it's going to want the one where it's easily able to identify the vertex. If you are in standard form, the vertex is hk. We've seen h and k's before with our circle equations. With our circle equations, it was x minus h and y minus k. There were minuses in front of both of them, so we used the opposite number of both. In this formula, there's a minus in front of the h, but there's not in front of the k. So what that tells us is we use the opposite of this number to get the x coordinate, but this value that you see on the outside is the y coordinate. You don't have to take the opposite of it, okay? So if I had like x minus 3, my x coordinate would be a positive 3. If there was a plus 4 out there, my y coordinate would be a positive 4, just exactly as I see it. The other information that they're talking about here is about mins and maxes and which way it opens, which you can really just kind of look at the right side of the screen there for that. If you have an a value that's greater than 0, your parabola is going to open up, and you're going to have the vertex, which is the either the minimum or the maximum, at the bottom. So the vertex would be a minimum value. If your a value is less than 0, it opens down, and therefore the vertex is a maximum value. Okay, so just little pieces and parts here. Make sure you know what both forms are. Make sure you know how to find the vertex, hk, and then make sure you know those little pieces to the right there about if something's positive or negative, which way it opens. And if you can visualize that, that should be enough to figure out if you have a min or a max. Okay. All right. First problem we're going to do, it says find the standard form of the quadratic function f, whose has a vertex of 1, -5, and passes through the point 3, 7. And then after we find the equation, we're going to answer, does this have a minimum or a maximum value? All right, standard form is this guy. A x minus h squared plus k. Do you need to know that? Yes. All right. You need to be able to find 3 things. You need an a, an h, and a k. Once you have those 3 values filled in, it's kind of like when we did y equals mx plus b. We always wanted an m and a b. Now we want a, h, and k. Once I have those 3, I have my equation. H and k come from your vertex. So I have those, kind of. X minus 1 plus -5. Or you could just write -5. Would be fine. Okay, so fill that in. The only thing I still don't have is an a value. And what have I still not used yet? Well, I have this other point, 3, 7, and that's an x and a y. Think about when we did our line problems, when we had a slope, but we didn't have the y-intercept, we plugged a point in to solve for that y-intercept. If I plug a point in, it gets rid of the x and y, and I only have one variable left that I'm able to solve for. So that's what we're going to do. We're going to plug 7 in for y, and we're going to plug 3 in for x, and then we're going to solve for a, which is the last thing that's missing. So 7 equals, if I do 3 minus 1, just order of operations, do my parentheses first, I get 2, and then square it would be times 4 minus 5. To solve for a, add 5 to both sides of the equation, 12 equals 4a, and therefore a is 3. So I have A, I have H, I have K, fill them in, final answer. Y equals 3. X minus 1 squared, I'll just write minus 5. And then from this A value, you should be able to answer a bunch of stuff. Does it open up or down? Opens up. Does it have a minimum or a maximum? If it opens up, picture that. Where's the vertex at? At the bottom, minimum. Okay, and that's also going to help us later figure out like what the range of these problems are. Domain of these is always going to be what? What's the domain of a quadratic, a parabola? Yeah, range is 0 to infinity. What's the domain though? My x's. Yeah, negative infinity to infinity. Domain, we have no restrictions on these, right? And guys, this whole chapter up until like the very last section, we're talking about stuff that always is going to have domains of all real numbers. Things you can plug in whatever you want. No fractions, no square roots. We're going to kind of steer away from some of those weird basic functions and go back to some of our normal ones, which would be nice. Okay, next up. Converting a quadratic function to another form, we use completing the square. We have already done this together before when we talked about circles a couple chapters ago. So this information is already in your notes. We're not going to spend the time to write it down right now. I just want you to have it on here. It is in Polaris if you need to refer back to it, okay? We're just going to do some examples together, starting with this guy. We're going to convert it to standard form, so that's the one with the parentheses squared, and then that should be able to allow me to find my vertex fairly easily. So go ahead and write the first one down. Y equals x squared minus 2x plus 2. Completing the square, just like we did with circles. It's actually a little bit easier than we did with circles because only one variable squared instead of both variables squared. First step was we want the variable that's squared all by itself. We want the x's together. So I'm going to move that 2 to the other side. That's all you do in the first step. The second step, if you look at the instructions, says factor out the number in front of the x squared. In this problem, is there a number in front of the x squared? There is not, so we just skip that step. Third step is the actual completing the square step, where we're going to leave a little space on each side. And we are going to add a number to both sides to balance it out. Remember, to find that number, we half it, square it. Write that down in your margin somewhere if you want. Half it, square it is where this magic number is coming from. So if I take negative 2, the number in front of the x is the one we're using. Half of it is negative 1, square it, 1. Okay, so I'm going to add 1 to both sides. That means on the left, I'm just going to have y minus 1. And on the right, this is something that you should be able to factor, and it factors really nicely. What multiplies to 1 and adds to negative 2? Negative 1, negative 1. So I could write x minus 1, but instead, we're always going to write the parentheses x minus 1 squared because that's what our vertex form, our standard form, looks like. Last step is just get the y alone. X minus 1 squared plus 1, and that is your final answer. Now, here's how you can check this. There's a couple ways you can check it. Number 1, this is the same equation. So in your graphing calculator, you can graph the original problem and your answer, and if they are the same equation, what should it look like on your graph? The exact same. So if you graph them and they look the same, you have done the problem correctly. Let's say you don't have a graphing calculator. This, again, is the same as that. You could FOIL this out, and it should, again, take you back to where you started. Okay, so that's how we would check it algebraically. Once you have your equation, you should then be able to name the vertex. Remember, it's the opposite of the number inside the parentheses and the same as the number outside the parentheses. So the vertex here would be a positive 1 and a positive 1. Okay? All right, let's look at one now that has a number in front of the x squared. What's going to happen if there's a negative 3 there? First step is still the same. I'm just going to move that 11 over to the other side. Y plus 11 equals negative 3x squared plus 18x. Now this time there is a number in front of my x squared. So the second step says, if there's a number in front of the x squared, factor it out. So that's what we're going to do. We're going to take negative 3 and we are going to separate it from our x squared, kind of like what we were doing with our transformation problems, right? We want to keep the x in there. We just want to move the -3 away from it. If I divide both of those terms by -3 on the right, what am I going to be left with? X squared minus 6x. Okay, now that completing the square step, we're going to leave a little space on each side. On the right, it's going to go inside the parentheses. Is where we're adding this number at. All right, look at the number with your x, -6 in this problem. Half it, square it. Half of it is -3, square it. 9 is going to go inside the parentheses. I am not going to add 9 to the other side, though, because that wouldn't keep my equation balanced. What number should I add to the other side? Sebastian? Yeah. Isn't that -3 multiplied by that 9? So really, when I put that 9 in there, I added -27 to that side. So I need to make sure I add the same amount to both sides. When you look at the instruction, it doesn't always say add the same number to both sides. It's add the same amount to both sides because of situations like this. All right, then the rest of it's the same. I've got a -16. If I put those terms together, and I can factor that trinomial I created. What does x squared minus 6x plus 9 factor to? Something squared. X minus 3. Yep, x minus 3, x minus 3. Good. And then last but not least, move the 16 over. X minus 3 squared plus 16. Can you tell me the vertex? What is the vertex? +3, perfect. +16. Any questions? Completing the square. Okay, and again, if you want to go the other way, if you want to go from standard form to general form, you just FOIL it out. That's all we're doing. FOIL, distribute, add like terms. You know how to do that. All right, next. When you complete the square, we actually end up doing the same thing over and over again. And so somebody figured that out back in the day. They're like, if I don't need the whole equation, if I just need the vertex, these same steps are repeated over and over again. So we can do this instead. If you have an equation that's in that general form with the ABC, and you want to find h, to get h, you're going to use -b over 2a, or the opposite of b over 2a. Do you recognize that from Algebra 2? That's also in our quadratic formula, isn't it? The -b is on the top and the 2a is on the bottom. So you've kind of got it already in one of your formulas that you know. That's really all I would care to know, honestly, because the second part of the formula says how to get a y that goes with an x. We already know how to do that. If I have an x and I want the y that goes with it, I just plug it into the equation. That's what that second part's saying. F of -b over 2a means take your x that you found and plug it into the formula and get the y. And that gives you your full vertex. Okay, so the x coordinate of my vertex is -b over 2a. X equals -b over 2a is what we call the axis of symmetry. The axis of symmetry is, if I have a parabola, the vertical line that goes through your vertex. So it's kind of a twofold. It gives me the x coordinate of the vertex, and it also gives me the line of symmetry that'll cut my parabola in half. It's all one thing. It's all found the same way. All right, so we're going to use this problem. We're going to figure out, does it open up or down? We're going to find the vertex, min or max, axis of symmetry, and then I'm going to add a couple little other interesting things to this as well. All right. First of all, can you tell me if it opens up or down? Opens down. How do you know it opens down? Because of the -4. Perfect. If it opens up or down, down in this case, does it have a min or a max? Oh, picture it opening down. It's going to have a maximum. Okay, next thing we're going to find is the vertex. To get the vertex, which will also give me the axis of symmetry, I'm using this formula. To get the x coordinate, -b or opposite of b over 2a. What is the opposite of b here? -12. 2 times a, 2 times -4. -12 over -8 is going to give me a +1.5. So if I asking for axis of symmetry, the axis of symmetry is x equals positive 1.5. You must have the x equals in front of it because that's what makes it a vertical line, a line of symmetry. So anytime you're listing axis symmetry, sometimes called line of symmetry, make sure it's x equals whatever the x coordinate of your vertex is. Now, once I have the axis of symmetry, my x coordinate of my vertex, all I have to do to get the y is plug that x into the equation. Negative 4 times 1.5 squared plus 12 times 1.5 plus 7. What does that give me? 2.25 times negative 4 is negative 9, plus 18 is positive 9, plus 7 is 16, and that's my vertex. 1.5, 16. Okay, I figured out which way it opens, figured out if it had a min or a max. Axis, symmetry, and vertex go together. Can you tell me the domain of this equation? That's easy points on a test. Negative infinity to infinity. No domain restrictions. Can you tell me the range? Without graphing it, without finding an inverse. Very good. Look at Creston. Negative infinity to 16. Would 16 have a bracket or a parentheses? Bracket. Now, why is it 16? Isn't that vertex my maximum point? Couldn't we like sketch that? Use that little blue graph at the top. That point, imagine, is 1.516. And I know it opens down, and I know that's the maximum point, so doesn't it make sense that that's my range? And if it's a minimum point, it's just that number to infinity. Okay, so it's always going to be infinity or negative infinity to a number. The other thing we can do, since we already have the vertex, is to put it in that vertex, that standard form. When you go from one form to the other, the a doesn't change. A is a, still negative 4. Okay, but we need an h and a k. Well, aren't h and k our vertex that we just found? And h was negative 1.5 and k was 16, or positive 1.5, so it'll be negative in the formula, and k is 16. Isn't that the same answer I would get if I completed the square? Isn't that easier than completing the square? To just find the vertex and plug it in versus doing all the completing the square steps? So if you're doing a problem on the homework and it says convert to standard form, you have completing the square that you know how to use, or you can just find the vertex and plug it in knowing that your a is not going to change. Make sense? Questions? Great. All right, so let's put all those things together now. We are going to graph a quadratic, and we're going to find all the pieces and parts. Okay, and we're going to do it in both forms. We're going to do one of them in standard form and one of them in general form. This guy's in standard form. When you are graphing, the first thing that you need to do is name the important coefficients. In this case, the coefficients aren't A, B, C. They are A, H, K. What is A? Negative 2. What is H? Negative 1. And what is K? Great. Great. Okay, which way does it open? Down. Min or max? Has max. Okay, what is the axis of symmetry? Close. He said negative 1. I said close. And that's a vertex. We're going to get to that. X equals. That's easy points. We don't want to lose it, right? X equals negative 1. It is a line. Better be an equation when you answer that. What's the vertex? Negative 1, 3. Good. Okay, other things we can find that will help us get a graph. So you can always, at any point, make a table of values. We know how to do that. Let's find x and y intercepts. This is review. How do I find a y-intercept? 0 for x. Yep. So that would just be -2, 0 plus 1 squared plus 3. If I plug 0 in, what am I going to get out? 1 squared is 1 times -2 is -2 plus 3 is 1. So I have a y-intercept at 0, 1. Let's get x-intercepts. Sometimes more than one of these. Sometimes none. Just depends where my parabola is at. X-intercepts are when y equals 0. That's my f of x. 0 equals -2, x plus 1 squared plus 3. Now you can FOIL this out if you want to, but I think that's a bad decision because there's only one x here. So I should be able to just get this x alone. How do I get this x alone? First step. Subtract 3. -3, and actually let's go ahead, well, no, we'll do it in separate steps. Take that back. Okay, subtract 3, I get -3, then what? Divide by -2. -3 divided by -2 is going to give me positive 1.5. X plus 1 squared. Then what? Square root. So plus and minus. Don't forget your plus or minus. Square root of 1.5 equals x plus 1. Last step to get x alone is what? Subtract 1, and usually we're going to put it in front of the plus or minus. So -1 plus or minus. Now those are exact answers. That's kind of hard to graph. So I'm going to figure out approximately what those are. So my x-intercepts are approximately, if I use the plus, I get about 0.22. And if I use the minus, I get -2.22. Again, those are my x-intercepts. Okay. All of this is actually a little bit more information than you really need to get this graph. Let's put it all together in the picture. So my vertex is the most important part. -1, +3. I know that that is the maximum point. So I know there shouldn't be anything above that. I know it's also going to be the middle of my parabola, and that is where the axis of symmetry, the line of symmetry, is located. Okay. I have a y-intercept on my y-axis of 1. I have an x-intercept of approximately 0.22 and -2.22. And that's enough to get a picture, which you can very easily check with the calculator if you want. What's the domain? Negative infinity, infinity. What's the range? Negative infinity to 3 bracket. Good? Questions? Okay. So let's do, what time do we got here today? 12:11? Oh, we're good. Okay, this can be our last problem. I'm going to have you guys work on this, and I'm going to, everybody get with a partner at least. I'm going to have partners put answers up on the board. We're also going to put domain and range up here. Okay, domain and range. Only difference with this problem is it is not in that form we just practiced. So option number 1 is you can put it in that form we just practiced, or you can find the vertex and kind of work backwards from there. All right, however you want to do it. All right, I'll give you a little bit of time. Go ahead and get started, and I'll let you and your partner know what you are in charge of. Okay, we'll finish it up tomorrow.